picking up from where we left off last time, let's talk about voltage dividers. So series circuits are called a voltage divider circuit. Why? Because as you saw last time when we were doing all the mathematics with this, it literally divides voltage, right? So we have a different formula that's a way to find your voltage if you're using this formula. So the voltage divider formula states that the voltage drop across any resistor or resistors is equal to the ratio of that resistance value to the total resistance multiplied by the source voltage. Okay? What that translates to. Okay? This is the formula right here. So, to write it a little bit bigger, we have R1 divided by R total multiplied by voltage total is equal, or we'll find your voltage of R1. I guess I should say voltage and resistance of N, since it's not restricted only to resistor 1. Number, just random number. Multiplied by your voltage total. Gives you your voltage of that resistance number. So, and what they... Yes. So for this one, they give us our voltage total as 10 volts. So we're going to end up multiplying that by resistor 1 is 50 ohms. We're going to divide that by 150 ohms so that we can find what voltage at R1 is going to be. So 50 divided by 150 gives me what? 0.33 times 10. Should be 3.3 volts. Double check the number, guys. All right. So did everybody get 3.3 volts? So that is a voltage divider formula, guys. So you might want to write that down in your notes because we will be using it at points. And it is a good test question. The next thing we're going to be talking about is troubleshooting. How many of you have ever done any form of troubleshooting? Everybody? So we're going to talk about how to troubleshoot an open circuit. And that's checking for opens, how to identify it, checking for shorts, and identifying shorts. And with shorts can at times come short circuits, but with series circuits, they're less likely. I won't say they're unlikely, they're less likely. And the whole point of me saying it's less likely is because series circuits, by their nature, if one resistor goes out, everybody else picks up the slack of that resistor. When you might have a short circuit is if you take out one of the big resistors. Then you might have a problem. But then again, your current will drop quite a bit, so maybe not. Like I said, series circuits in and of themselves are stable from shorts and short circuits more so than parallels. Like I said, I don't say it doesn't happen, just less likely. Okay? All right. So let's talk a little bit about troubleshooting. I'm going to start off by talking about what a short is. So this is an undesirable path for current to flow. It decreases the amount of resistance in a circuit. So you identify a short by looking for a drop in resistance. Does that make sense? So the total current in the circuit increases, the resistance decreases. Why does that happen? Because resistance and current are on a what? You don't change your voltage, resistance and current are on a seesaw. One goes up, the other goes down. That makes sense to everybody. So if current will increase, that means your resistance has decreased at some point. So a short occurs when the source conductor and return conductor, so short circuit. Short circuit, no, I'm not talking about the movie. Number 5 alive. Motorcycle. Huh? There's a movie called Short Circuit. It's about a robot that Johnny Five. Yeah, there you go. He got hit by lightning and got a short circuit in his system and started talking, making wisecracks, and running away from the U.S. government. Very cute movie. Look it up. Very old production though, so don't be judging. That came out in the what? 80s or 90s? Very, very old movie. Yes. Semi-sophisticated. Especially when you take in the fact that it's old. So a short circuit occurs when the source conductor and return conductor come into contact with each other. This bypasses the resistance of all the loads, and it's not a good situation. Now, again, series circuits are not so prone to this. Parallel circuit is every short becomes a short circuit. So, yeah, not good. So sources of shorts are things like incorrect splicing or termination, defective loads, excessive current that burns off conductor insulators, or conductive items falling into a circuit. In other words, about the silliest thing you could do, I'm going to say silly, not a different word, would be to take a piece of wire and stick it in both holes of a socket. That won't take long to burn off. One of the, I got into watching life hacks the other day. One of the so-called life hacks was somebody took a battery, like a A-cell, D-cell kind of battery. They took gum wrapper, put the metal side to both terminals, and were able to start a fire with that battery. because they created a short circuit. Because the gum wrapper has how much resistance? Nada. Big zip. So yes, you can create a short circuit with a battery. Not something I would generally recommend because it kind of trashes the battery. Not to mention you can and will induce start a fire. Now, if I could find a bad battery somewhere, I might, be tempted to kind of show off on that, but not tonight. Not a good idea tonight. I don't feel like starting a fire. Excessive current burning off conductors, insulators does happen. How many of y'all go excessive with the lights at Christmas time? And it's okay to admit it. This is a safe space. And admitting you have a problem is the first step. No, but seriously, if you put way too many strings of lights on the same cord, it actually will pull enough current that it will catch fire and can burn off the insulation. At which point you're going to end up with an arc over. So, much as you like Christmas cheer, don't bring it down to only one power cord. It's not a good idea.
Strips. Those plug strips.
Power strips?
Power strips, yeah.
Talking like.
Yeah, like these, honey.
Yeah, the ones I've got around here.
Right.
Yeah, power strips are safer, but there will be people that still overload the power strips because you can. Now, if there's surge protected power strips, you can't do that because the surge protector starts reading too much current and goes, nah, you're not doing that.
That's what I got on my TV.
Yes, you should. Because here's the funny thing that nobody ever talks about as far as storms. If lightning hits, believe it or not, all the lightning energy goes into the ground. It doesn't dissipate quickly. You can be about 5 miles away and still get hit by that lightning strike. It will burn out everything in your house. Mm-hmm. That's why you're supposed to put surge protectors on all vulnerable electronics. Because when lightning hits, let's say lightning hits in Pleasant Grove, the power of that lightning, the electrons and all that, if it gets into the right system and it just starts traveling everywhere. Because what nobody realizes about lightning is that that's nothing but voltage and current. There is no resistance, or very little resistance in the air. So you are getting pure voltage and current, because all of that's nothing but electrons that are being attracted to the ground. So when that lightning strike hits the ground, all those electrons are not going to just sit there and go, okay, now we're on Earth, we're good. No, they sit there and go, okay, let's go cause some mischief. And if they hit the right wires, they're going to burn out everything around them. Now, what would be cool is if one day somebody designed a system that was strong enough to handle a lightning strike and harness it. Think about Tornado Alley, where they have tornadoes, like F5 tornadoes. But along with those come really severe storms, right? Be able to gather that lightning from the sky and use it to power homes everywhere. That'd be kind of cool. Down here in Alabama, we get that all the time. What we have as far as technology to do anything with lightning these days, though, is still very rudimentary. What we mainly do with lightning is we put a lightning rod up so that when lightning strikes the lightning rod, where does it go? It takes this nice long copper wire and follows it to ground. Why? Because we don't want to deal with it. Seriously, if you've ever seen lightning strike anything, it strikes a tree that's been soaking in the rain and catches it on fire. Come on. That's some voltage and current that's running, right? So, yeah. Let's talk about shorts again. Short circuits. So all circuits must have resistance. If not, then according to Ohm's law and Watt's law, current and power theoretically can go to infinity and beyond. Sorry, for some reason that triggers that joke out of me. So of course the current flow will never go to infinity because if the load is bypassed, the circuit will be limited only by the resistance of the conductors and the resistance of the voltage source. They don't have much resistance. This is the point where you generally see bad things happen. So when all the loads in a circuit are bypassed, it's called a short circuit. When a short circuit occurs, something's going to give up, either your voltage source, a conductor, and if you're lucky, hopefully, what gives up first is the overcurrent protection device, aka in your house, the circuit breaker. In some delicate electronics, you got fuses. But in your house, most houses, I will not say all because not all have been converted over. Most houses have circuit breakers at this day and age. Why? Because most homeowners know, oh, the power went out. Maybe I need to go check the circuit breaker. Circuit breakers pop it back over, you're good to go. Versus Joe homeowner playing with the fuse box and not knowing what he's doing. There's a reason we got fuses at home. Not the least, pretty sure many homeowners association and the builders kind of got tired of getting sued for something that really was the homeowner's fault. And if you've ever seen what some people cobble together as far as electricity when they're homeowners, it's some scary stuff, my friends. And they bypass the overcurrent protection device to do it. At that point, I'm sitting there going, enjoy your Darwin Award. Seriously, how many of y'all have ever watched something like HGTV? Where they build the houses and stuff like that, or they go remodel houses, and you're just sitting there looking at the wiring and going, oh, don't touch that. No, don't touch that. I see bad juju in your future. Don't touch that. Exactly. If you get the contractors that are involved, those are the ones that you sit there and go, okay, yay, somebody actually knows what they're doing. If it's just watching homeowners tear down their own house and try and rebuild what they're going to do, oh God, you just sit there and pray and go, oh, please don't touch that. Please don't touch that. Oh, no. Personally, I'm waiting. I wait on some of those shows for somebody to touch a live wire. The ones that take down the support for the ceiling and the walls and all that. Yes, it does. Or it sags over time. Yeah, that's always the one thing where I'm a big fan of people getting home inspections. But I'm also the big fan of if you get a home inspection, go with the inspector. Ask questions. Point at something and go, that's a giant crack in the wall. Should that worry me or is that just the house settling? Oh, You know, I didn't notice that right away, but you're right, that is a giant crack. but I'm pretty sure that's not a good thing. Asking questions works. It will keep you in a far better state of mind. And that's what a lot of people don't do whenever they're buying houses or they're renovating. They don't ask questions. They don't go up to the home, somebody that knows what they're talking about. My sister ended up buying a house that was a total dud with a friend of hers. I looked at the home inspection and went, no, too many red flags. No, oh, don't do it. Don't do it. You're gonna waste your money. You're gonna waste your time. Don't do it. They bought it anyway. Because who listens to little sister? Nobody. Oh, you mean you was? Huh? There was mold in the walls. At the very least.
What made you say? What made you think it was, like don't buy it?
There's several things. For me, I always look at the pictures. I've watched so much HGTV. I've binge watched it a lot. So one of the things I kind of started to do is pick up on what a lot of these home inspectors see when they're looking at the house. I start looking for things like water damage. What does the roof look like? How soon is that going to have to be replaced? You look at the walls, the mold, and the trimming. You have to kind of start looking beyond what the face of it is. The pergola they got out back was probably one of the biggest clues because they self-built the pergola and the thing was falling over. Another big clue, bunch of glass all in the rocks under the pergola. Things like that, just kind of sitting there going, no, not a good idea. No, I don't think that's a good idea. Okay, don't listen to me. I said nobody ever listens to me. Oh well. So, yeah, at one point they figured out that there was mold that was causing a lot of allergy issues. So my sister took, the carpet tape they put down in model houses so people can walk through a house without messing up the carpet. The giant, yeah. She was using that to tape up everything. All around the baseboards.
Well, that mean they had to come in and take all that stuff out. Take all the
Oh, more than likely. Like I said, nobody asked my opinion. Nobody that asked my opinion took it seriously. I saw the home inspection and I just started going, I don't like it. Nope, I really do not like it because I'm seeing signs of this, that, and another, and there are so many alarm bells are starting to ring. No, it was on a slab. But it just was not a well-built house. And whenever something's not if you're not sure of something, I'm one of those people that I like listening to that alarm bell in my back of my head and going, okay, there is something majorly hinky about this. I need to probably look at it a little closer. I'm one of those people, I'll stick my head in the attic and go, okay, we got like major signs of moisture damage. Not necessarily, because they have such good dehumidifiers these days. You're not necessarily going to smell it. Basements are one thing, I'll give you that, but they're not the only thing. Slabs are vulnerable to other problems though. Our old house, the one in the middle of Hoover was on a slab. However, there's a problem with that whole section of the neighborhood, and that's because it's all on fill dirt. Fill dirt. You know what that means?
It should sell.
It's going to suck. It means that all they did in order to make that area, they brought in dump truckloads of dirt.
And they didn't let it settle in, so what happened? country
We
should.
were losing our whole backyard off the back embankment, and they put out enough of a problem that the whole neighborhood got together and sued the builder, and had to put a retaining wall in along that whole section of our neighborhood, including our backyard. We had lost about a foot, maybe 2 feet of our backyard down that embankment. Yeah, it was nasty. Also had a neighbor that put steps in down to the lake that was behind us, and they were suing him last I heard for that. But I digress. One of the things that you would never really kind of think about though with something like that is the fact that if you went into our laundry room, we had all our floors tiled. If you walked in our laundry room, you could see cracks in several parts of the floor. Same thing in my parents' bathroom, where the slab was cracking because of the settling of the dirt. That is not something that most people look at and go, oh, I know what that is, it's just settling. But the other problem with that settling and the cracking of the foundation is you get water in your foundation. They waterproof your foundation on a solid slab because you don't want moisture leaking into your floor. If it's wood floors, it's going to tear them crazy. If they're tile floors, you can actually dissolve the mortar. There's a lot of problems with that. That's the kind of stuff that I look at and go, yeah.
I'll tell you something else too. They could have not put no good concrete in.
Exactly.
Because, and then.
Well, considering this builder, and I do know who the builder was, and I do know his reputation, he was a lazy, thieving so-and-so. Because he bought a bunch of nails on and used for everybody's house and used them on.
A lot
So.
of people don't like, I think it depends on what person DR Horton used, but a lot of people do not like DR Horton. A lot of them.
That's because you can end up with very inferior materials if you don't really know what you're talking about. A lot of people in this day and age, they like to look at magazines and go, oh, this is my dream house. You're given a picture and go, oh, this is my dream house. And whenever somebody like DR Horton comes along, oh, that's the dream house I want. And this is what I want from this dream house. Here's the thing that nobody looks at and says, okay, well, do you know the materials you want exactly? Do you know how it's supposed to be installed professionally? Do you know anything about what you're actually talking about? No, but it's my dream house. At that point, I'm one of those people that I sit there and go, yeah, karma's gonna kick you bad. It's one of those, ignorance is not bliss. If you're dealing with somebody that could very well be a shoddy builder or a shady builder, the best thing you can do is arm yourself with the knowledge to really help yourself. Does that make sense? If you have the knowledge to stop somebody from messing with you that way, if you know what the code for that is, or you at least know a little bit about it, a little bit of knowledge can go a long way. Knowing how they're supposed to be hanging cabinets, knowing how wiring is supposed to at least look. What are the wiring codes, at least to some degree? I'm not saying you're supposed to be an expert. I'm saying that maybe you need to make friends with somebody who is, and maybe walk them through the building of your house every now and then. You know, there's certain ways you can protect yourself. And a lot of people don't because they don't think about that particular aspect of it all. That's how a lot of people end up getting burned. I've seen it happen quite a bit.
Then when you try to tell a lot of people stuff, they say, hey, you just hate. And she was like, man, I'm trying to tell you this, but you wait, you don't want to see me with it.
And again, that goes back to the, yeah, you're gonna get it hard and you're gonna learn the lesson the hard way. Okay. I mean, that's what my sister ended up doing. She learned that lesson the hard way. I drove by that house again since then, and that house looks really terrible.
And everybody saying that's what to do, build again next year. And the land I'm looking at, when it's storm, I go when it rain real hard, or real bad, when it's flooded. And I go to that land, whatever land that I'm looking at that I like, and I watch that land, and I look at that land to see how much water is retained on that land.
Mm-hmm.
You know, but I did it before. I got the house that I'm in now, I got it built. So I did it before, but, you know, when just looking for the right building, you know, that's very important, looking for the right building. Because some people get this Chinese, they still get that Chinese sheetrock,
Mm-hmm.
and they hanging it up on these houses. Some
Knowing your
people-
product is probably the biggest fight that you have with most builders. Because most builders, how to say this? They can. I know there are good builders out there, and I don't mean to misalign them. I don't mean to demean them. There are good builders out there that will do it the right way and will get the right product. But just as many good builders are out there, it's kind of like good guys versus bad guys in any kind of life. Yes, you have the good guys. You have the white hats, the ones that are going to save everybody. But just as many white hats you sometimes have the same, if not more, of the black hats. You have the people that are not in it so much to help people live in nice houses, or not meaning to give people what they think they want. What they're doing is they give people what they want to see. And they'll do some really shoddy things. I've seen it happen to a lot of people. And the thing is, it's not just the builder's fault. If you're the homeowner that's paying for it, you need to make sure you're paying very close attention to what you're buying. Because think about it this way, they're getting paid based on what you are letting them buy. Okay? The opposite of that is that if they can get away with buying something cheaper and make it to where you don't know about it, they make more money. They pocket that money.
Well, my thing is the person's smart.
Most homeowners are not that smart.
But
We disagree with
personally, I tell you, me personally, I want to see all the materials involved.
You should. That is something that everybody should do, is that whenever you're looking at buying a house, you should see every material that's bought. You should oversee at least some of the installation and know what you're supposed to be seeing. I'm one of those people, I don't trust easily. So I want to be deeply involved in everything that they're doing and sit there and be able to go, no, can you please make sure you're installing that right? You don't know how to install this correctly? Well, here's pictures in the how-to book. Now go back and install it correctly.
And I just say, you can't do the job, just let me know that a ski zip was, that's the zip from having this right here. That's all I say, and I have encountered a few like that, and they witness the book.
Some of them just honestly don't know what they're doing. So they generally will hire somebody that does, but those that don't.
All right, getting back to what we need to talk about, guys. Enough hot water stuff. Let's talk about short circuits. Y'all get me off topic. I swear, sometimes y'all get me so far off topic. So when current flows through the small resistance of the conductors, you generate a lot of heat. Okay? When metals are heated, their resistance goes up. When the resistance goes up, you get more heat. And if something doesn't stop it, conductors can get extremely hot and melt or cause a fire. Okay? So we use fuses and circuit breakers to try and bring that to a halt, but sometimes it ends up being like a runaway stagecoach. You ain't catching it. And most of the time, where are these wires that are going to be short-circuiting? They're behind a wall. That's why if you're ever walking by a wall and it feels really, really hot, you might want to investigate. Okay? If you see any part that looks like it might be burning or your paint is peeling or drying out, you might want to investigate. And for those of you that don't know the signs of water, generally it's the sheetrock becomes soft, the paint can bubble, and yeah, there's several signs. And you really do not want water and electricity to ever mix. It does not mix well. Okay. So fuses and circuit breakers automatically create an open circuit when the current rating is exceeded. The bad part about fuses in homes is that we, just like circuit breakers, tend to put them to just a little bit better than, or a little bit worse than, depending upon your electrician. But they try and look at the wire rating and put that circuit breaker right at that wire rating. Why? Because you want the circuit breaker to give it up before the wire does. That's just the fact of the matter. That's why we don't use fuses anymore. Bigger fuse does not mean you get to keep everything. It just means you created a ticking time bomb in your house. Okay. These are something how many of y'all know where the circuit breaker box is for your house? Everybody should know, right? I know ours is in our basement. Most of the time they're either in the basement or they're somewhere close to hand where nobody's going to be in contact with it regularly. Not in a crawl space. It needs to be accessible, but you don't want a kid playing in it. Let me put it that way. Short circuits are not something that anybody wants to deal with. That's why we use circuit breakers. All right. Sounds like fun. All right, so instances of a short, okay? So a short is it's basically your load goes away. It makes it to where there's less resistance. Less resistance is more current, more amperage, yes. This part right here is a short circuit. That's the one you really do not want because that hopefully will trip your breaker. If it doesn't, you are in some very deep trouble. I told y'all that I had a plug go bad on me, right? For the night light. I wish I had kept that plug and the night light because they melted. They melted together really kind of interestingly. Still not a good thing to have happen, but it does happen. There's not a lot you can do to kind of stop it. So to prevent shorts and short circuits, it's imperative that the conductors in a circuit are isolated from each other. So we use insulators to do that. And they're supposed to also protect it from the environment. Now, funny enough, let me go back to that one because I see some of y'all are trying to write that down. Transmission lines, do you think they're insulated? They are not. The major transmission lines are not insulated.
I don't know the science behind it.
It's to prevent heat.
Oh, so it would get really hot and it could actually cause a melt.
Well, we'll put it this way. You're running tens of thousands of volts down those lines, pushing all that current.
Wow.
You do not want to overheat one of those lines because it could and I don't know that an insulator would last very long against it.
Yeah.
So the major transmission lines that you see out on those big wire frames, or the big metal frames, those are aluminum, and they're not insulated.
Oh, so they're covered with aluminum.
No, they are aluminum.
Well, I've seen people like wrap them up. You know, I'm talking about some sections of the line.
They might be trying to make a splice or something, but I'm not quite sure what you're talking about, but that might be just trying to put an end to something.
I got you. But it was out.
One of those big ones, those are made of aluminum. Why? Because aluminum. How about put it the way, I'm going to say it a little bit of a different way. Aluminium, and no, I'm not talking adamantium, I'm talking aluminium. Yes, I just made all of y'all laugh with a really bad Wolverine joke. I'm sorry. Aluminium is how most of the world pronounces it, and it's a little bit easier for me to say right now. So aluminium is the main one that we use for transmission lines. Why? It's light, it's cheap, and it's readily available. Now, why would we care that it's light? Well, because you're talking wires that can be the diameter of your leg. Everybody look at your leg and imagine that that's a wire that size. How much weight would that one piece of wire be?
About 40 pounds. About 30, 40 pounds.
They can be the size of a man's leg. They're huge. And you're using this to push thousands of volts, and we're not even going to talk about how much current through these lines. And here's the thing, you have to string these miles apart sometimes. Okay? So you want something that's light. Why? Because eventually it will droop, it will sag.
Especially with the wind and stuff.
There's a lot of ifs, whens, and everything else. So it's really a good idea to have a material that is light enough that when you're putting it into a transmission line, such as these, you do not want anything that's heavy. And copper is very, very heavy. Second problem would be the fact that copper is, what is copper worth these days? About $5 per pound or more? Copper's got extremely expensive. Copper's been extremely expensive for a while. So here's the bad thing about copper being expensive. Because this has happened a lot. The power company, believe it or not, there are people stupid enough to rob the power company. They will break into substations. Yeah.
Don't they die?
No, not always. They break into substations. For those of you who don't know, substation is where a lot of electricity is brought in, broken down, and sent out to houses, or stepped up enough that they keep going down transmission lines. Not a good idea. Let's say that loud and clear. Not a good idea to break into a substation, because if you get the wrong part of that, you're going to be fried like a squirrel on a power line. Yes.
Somebody trying to cut the lines over the house with voltage, there is an impression. You see the outline there.
So he got going more?
He didn't do it again, let's say that. Oh, yeah, you see the impression. Well, they didn't show that it was active.
Okay, focus.
Yeah.
You're running a lot of electricity, voltage, and current on these lines. But there are people that
wire. Why? Because they want to sell it off for scrap and make money off it. And they do.
Quite frequently. There's a reason that these gates are guarded very heavily, and that why they are locked so tightly. There are people that still slip in, however, and it's a problem. So one of the things you do not want to keep around are large diameter runs of copper wire. So if you have something like aluminum, it's cheaper. Nobody's going to look at that and go, oh, you know what? I might take that down for scrap and see if I can get some money off it. How much money do you get off of aluminum? Not enough. It is pennies to the dollar versus copper. Compared to copper, it's not worth much. Okay? So copper is one of those things that we do not use because of those two reasons. It's too heavy, it's too expensive. Okay? Is it a better conductor than aluminum? Yes. But it is not so much of a better one that you cannot use aluminum for the same purpose. Okay? Especially since aluminum is so much lighter, it's far easier to string that than it is to do copper. That's another reason why it's used. Now then, one of the things you also have is straight from Silicon Valley. Well, not so much right now. Seem to be having a problem with deliveries from Silicon Valley these days, don't we? Anyway, so yeah. This is a computer, I won't say it's a computer chip. It's a circuit board. You can't even call it a computer chip, it's a circuit board. This is a circuit board. Okay? So what it uses to insulate is generally a mix of silicon and plastic. Silicon and or plastic. I'll put it that way. Now those tracings, which is what we call the lines that you see running along this, are made of a couple of different things. It can be made of gold, which by the way, the gold is so thin, it's less than the thickness of a human hair. So no, it is not worth going and finding a bunch of old computer boards and trying to get the metal out of it. You're going to waste more time and more effort than you'll ever get money for it. Okay? Tell you that now. They can also be cut in with silver and or copper. But still, it's not worth the effort to get anything out of it. Because you would have to, it is literally less than the thickness of a human hair. So if you've ever seen how thin a human hair is, it is less than that. Okay? Opens. An open allows for no flow. Okay? So if no current flows, no work is performed. It prevents current flow through the whole circuit if it's an open circuit. It's what light switches are for. Sources of open, on-off switch, which is a deliberate open, fuses or circuit breakers, which are a semi-deliberate open, faulty splices, faulty terminations, where wires just kind of spring apart. Nobody knows about it because it's generally behind a wall. Excessive current that causes conductors to melt. That is like the probably best case scenario you would hope for if you have a short circuit going on in your house. I'm not kidding. Yeah. So excessive current that causes conductors to melt. That is a best case scenario if you got a short, because that means that hopefully it gave out before it caught fire. Okay? Everybody good? Anybody need a second? All right, give you just a second. Everybody good? All right. So in a series circuit, all opens create an open circuit. Why? That is the one vulnerability of a series circuit. Any open is an open circuit because you literally are breaking the circuit. If you break the circuit, it's just broken. You can't fix it. Yes, I'm trying to move through some of these animations. Okay. So checking for and identifying opens in a series circuit. This is the most common failure of that circuit. It cannot always be detected visually because if you have a string of 500 Christmas tree lights and all of them have gone out, how would you detect it visually unless you can literally see the burned bulb or that a bulb is broken? You can't. So opens cannot always be detected visually. Total resistance becomes infinite, if I can speak tonight, because it is disconnected from the power source and total current should be 0. So you should not really put an ammeter to these things. It really doesn't matter. Okay. When tested with a voltmeter, total voltage will measure across the open. That is how you are generally going to find the open. Okay. Give everybody a minute if y'all want to write it down. All right. So checking for and identifying shorts in a series circuit. So shorts occur when two conductors touch, or if a particular resistor or resistive load gives out. So in a short, a part of the series resistance is bypassed and the current goes through the short. Again, a short, think short circuit or think shortcut, right? What you gonna go down? You're gonna go down the hard path or the shortcut? Everybody likes to go down the shortcut, right? So total resistance is reduced, total current is increased, and when tested with a voltmeter, approximately 0 volts will measure across that short. Okay? And these are just some good key terms. You have series aiding voltage, series opposing voltage, Kirchhoff's voltage law, the voltage divider formula, opens versus shorts, what happens to current in series, what are voltage drops, total voltage, total resistance, power dissipation, total power, and how does Ohm's law work in a series circuit? The same way it's always worked. All right. All that being said, we're not going to do more lecture tonight. Instead, we're going to see how well everybody does with some worksheets. Sound good? All right. No, but the one I'm going to be giving y'all for enforced study homework, I do have that ready, by the way.
Oh, that's the fourth study that we're gonna, test date for the
For the
final.
final ones, yes.
Yes, ma'am. Yep, first test, good turn. Yesterday I was on virtual, but.
I got you and I put you on as me here.
Yes, ma'am. Did you give out any worksheets? Because I'm thinking you
No,
got disconnected.
I did not.
Nice.
Guys, make sure you go through these packets because copier upstairs has been squirrely lately. You might have a page missing. If you do, I've got it up front. Yes, I do mean that it is actually acting squirrely. For some reason, it is, it'll spit a piece of paper out too far, or it'll throw it out too far, and all of a sudden I'm looking at a mess of papers that should be attached to certain things, but instead look like this. Which point I'm sitting there going, wait, what? Why is it not stapled all together like it should be? We'll talk about that in a minute. I want to look at the worksheet I just gave y'all first. How's that? Yes, it is 2 pages. Just laid them down somewhere there. But it is these 2 pages. Now, guys, I will say this. We're going to be in live on Tuesday. For sure. Okay? And Monday for the other class, yes. Okay? The reason we're going to lab so early is because this is a mostly lab class, guys. So we need to make sure if you do not have a lab book, I do have the ability to print the first 2 labs if necessary. You need to make sure